Today we are going to be looking at multiplying and dividing polynomials. All right, there's just one standard you have to worry about today. It includes multiplying and dividing polynomials, but there are several success criteria. All right, to be successful, you need to be able to multiply and divide polynomials by monomials. You need to be able to multiply binomials using the distributive property. You need to be able to multiply binomials using the FOIL method, and multiply binomials and trinomials. So we're going to do pretty much everything we're doing today is multiplying and dividing. All right, a couple vocab that you need to know. Distributive property is used to help you simplify algebraic expressions. It helps combine like terms and find the value of variables. This works with monomials and with binomials. You also can use distributive property with trinomials and other stuff too, but for this class, we're going to be mostly using monomials and binomials. The FOIL method is a method of applying the distributive property. It's kind of like a shortcut for multiplying two binomials. All right, example 1, multiplying polynomials and monomials. All right, A part says find negative 2x times 3x plus 7. All right, so when you see parentheses, you know that you are multiplying this by everything inside of the parentheses. So this is what we would call distributive property. So I'm going to multiply negative 2x times 3x, so that gives me negative 6x squared. All right, remember multiplying, now we're using properties of exponents. Same base, you add the exponents. So this has a power of 1, this has a power of 1. So when you multiply, you get x squared. All right, we also have negative 2x times 7, which is negative 14x. And that's all you have to do for part A. All right, B part, this is a monomial multiplied by a trinomial. So you're, again, because this is in parentheses, you're going to multiply the 3x squared times each term inside the parentheses. So I'm going to do 3x squared times 5x squared. So 3 times 5 is 15. And x squared times x squared is x to the 4th. Again, properties of exponents, when you have the same base, you add your exponents. All right, so then I have to go 3x squared times negative 2x. 3 times negative 2 is negative 6. Let me try that again. All right, negative 6. And then x squared times x. Remember, this is assumed to be the first power, so that's going to be x cubed because same base. You add the exponents. 2 plus 1 is 3. And then I have 3x squared times 6. 3 times 6 is 18. And x squared. All right, moving on to dividing polynomials. You can see in example 2, find x to the 4th plus 4x cubed plus 11x squared divided by x squared. So we can look at this as x to the 4th divided by x squared plus 4x cubed divided by x squared, and then plus 11x squared over x squared. All right, again, if you remember properties of exponents, when you have the same base, when you divide, you subtract exponents from top to bottom. So the first term is going to be 4 minus 2, or x squared. Here I've got 3 minus 2, which is just x, so this is going to be plus 4x. And then x squared over x squared, that cancels, and your x squareds are gone, and that just leaves 11. So that would be A part. B part, you can't just cancel y's, you have to have similar factors. When there's a plus or minus here, that means it's a binomial, and you cannot cancel part of that binomial unless you cancel the whole thing. So what can we do? hopefully you see that 6 and 30 both have a multiple of 6 inside. So if I take and I factor out a 6, I can say 6 times y, and then 6 times -5 is -30. So all I did was rewrite the top expression. So the denominator, you don't have to change. The numerator I rewrote as 6y minus 5. And again, 6 times y is 6y, and 6 times -5 is -30. So these two expressions are the same. They're equivalent. I just wrote this in a different form. All right, when I do that, I have a y minus 5 divided by y minus 5, and that will cancel. And so this will just equal 6. All right, so also you have a study tip here. Notice that in examples 2a and b that the denominators cannot be equal to 0. So for a part, x cannot be 0 because it would make the denominator 0. Remember, division by 0 is undefined, so it can't be 0. And then in b part, it can't be 5 because 5 minus 5 would be 0. So y cannot be 5 in b part, or this one would be undefined. So that's just something to remember when you're talking about division. All right, self-assessment. I want you to pause the video, try to answer these on your own. When you've taken a few minutes to do that, please restart the video and see how you did. All right, let's see how you did. So part A would be -88x to the 7th power. B part is 32y cubed minus 20y squared. C part, -18b to the 5th minus 3b to the 4th plus 27b cubed. All right, in example A from the self-assessment above, y is the degree of the product different from the degree of the factors. Okay, so the degree of the factors is 4 and 3, and the degree of the product is 7. So remember, same base, you add exponents. That's just your product of powers properties. So that's your properties of exponents that you need to know and be familiar with. And that will help you answer a lot of these questions. All right, the next question is the set of polynomials closed under division. Explain your reasoning. And the answer to that is no. By the quotient of powers property, the quotient may have a term with negative exponents. And a polynomial can only have whole number exponents. So if you end up with negative exponents, then that is not, that doesn't meet the criteria to be closed under division. Remember, to be closed under an operation, the operation performed on any two numbers in a set has to result in the number or the answer being in that same set. All right, example 3, multiplying binomials using the distributive property. All right, A part says find the product of x plus 2 times x plus 5. So you can see that the two binomials are both in parentheses, which means the x has to be multiplied by both terms in the second binomial, and the 2 has to be multiplied by both terms in the second binomial. So we can write that as x times x plus 5 and 2 times x plus 5. All right, so then we just multiply again. X times x is x squared. X times 5 is 5x. 2 times x is 2x. And 2 times 5 is 10. Now I can combine like terms. I see that these terms are like terms. So I have x squared comes down. 5x plus 2x is 7x. And then bring down my plus 10. All right, and that's it. That is your product of multiplying two binomials. All right, B part, again, we're going to do x times x minus 4. And then we're going to do 3 times x minus 4. So what I'm doing is taking the x and multiplying it by both of these terms and the 3, and multiplying it by both of these terms. So I'm going to have x times x is x squared, x times negative 4, negative 4x. And then 3 times x and 3 times negative 4. Again, combine like terms. X squared, negative 4x plus 3x is negative 1x minus 12. All right, example 4, multiplying binomials using a table. This is just another method to do this. So we're going to put x and 5 here at the top, and we're going to put 2x and minus 3 down the side. And it doesn't matter which binomial goes on top and which one goes down the side. But now we do 2x times x is 2x squared. 2x times 5 is 10x. Negative 3 times x is negative 3x. And negative 3 times 5 is negative 15. So this box method, again, is just another method of doing the same thing that we were doing in example 3. All right, then I take everything in the box. I've got 2x squared, and I've got negative 5x plus 10x minus 15. So I'm going to have 2x squared minus 5 plus 10 is plus 5x, and then minus 15. So that's how you multiply binomials using a table. All right, so let's go ahead and do this one as well. I'm going to move up just a little bit. So I'm going to put p and then plus 3 and then p minus 8. All right, I want you to pause the video, take just a moment, and see if you can fill in the table. All right, p times p is p squared. And I had p times 3, which is 3p. I had negative 8 times p, which is negative 8p. And negative 8 times positive 3 is negative 24. Combine like terms, I've got p cubed. These can be combined to get negative 5p minus 24. All right, so again, that's two different methods. This is distributive property. This is using a table. You'll get the same result, just two different methods to solve multiplying two binomials together.